Hi, welcome to Teardown Tuesday. We've got another classic vintage bit of kit for you. We love vintage gear here on the EEVblog. Thank you for whoever sent this into the mailbag. I forget who it was. It was quite some time ago. I'm actually clearing out, well, I'm going to try and clear out my backlog of Teardown items, and it's a Bobby Dazzler. Look at this. It is the Sony Video Walkman, the GV-9E for those playing along at home. POW, none of that NTSC rubbish. And this thing dates from about 1989. This wasn't the first video Walkman. The first one was the GV8 model, which had a slightly smaller screen, but otherwise very similar. It's got video 8mm tape recording, none of this disc rubbish or solid state rubbish. Good old analog tape, thank you very much. And you can't beat a product that has a telescopic antenna rod. Oh, beautiful. I could play with that all day. Whoa! So this GV9 model comes from a year later, 1989. I'm not sure when they manufactured it till, but yeah, late 80s design and construction, VHF and UHF, a standard play and long play mode. Thank you very much for playing. It's an absolute stunner. I did actually believe I got this powered up in a previous mailbag, so I'll try and link that in. But yeah, look at this thing. It's a Bobby Dazzler. The battery pack obviously went in here. I think it only had like a 1 hour battery life. I read on a website that this was actually, these Sony Video Walkmans were actually used on old Virgin Atlantic, I was going to say Virgin Galactic, Virgin Atlantic flights where first class passengers were given one of these video Walkmans and then a selection of 8mm cassette movie tapes to actually watch. So that would have been absolutely state of the art back in the day, and they probably couldn't watch the whole movie. I don't know, maybe they had to get another battery because I think it didn't have a very long battery life at all. Look at all the grills on the side for the airflow. Look at that. This puppy obviously gets bit warmsky. Anyway, we'll check it out. And yes, you could actually plug a camera into the thing and record directly from the tape. It's got VHF, UHF tuner, of course, and you could record TV directly onto the tape. But yeah, it was a high-priced niche market, and I think it was pretty much a flop, but it was the only thing available. Oh, hey, tilts up. Thank you very much. Ergonomics. Oh, beautiful. But it was, you know, it was state-of-the-art and pretty much the only thing that was capable of doing this back in the late 80s. So it was a technological revolution, even if it was a bit of a flop. Ah, well, you know what we say here on the EEVblog? Don't turn it on, take it apart. Now, it doesn't look like this grill comes off. It looks like it has lift points, but I can't get it off. And I was starting to take out the screws around here, and then I saw the good old Sony arrows. Look at that, the old Sony screw arrows, and just coincidentally, I've actually got one of those on my leg, where they did the teardown of my leg. Remove screw here, or insert screw here, as they did. So in theory, we should use the ones that have the arrows pointing to them, like this, and it should at least get the back cover off. Well, they seem to have failed on the arrows this time around. It's not really coming out properly, so there's still something holding it in. Bugger. But I'll tell you what, you take the 4 screws off the screen here and bingo, we're in like Flynn. Check it out. And absolutely no surprises for finding a glass delay line. It's upside down, so all the electrons are going to fall out. And click here if you want to watch a video on that I've done on how these glass delay lines work, and they're really cool technology. And this is exactly what you'd expect to find in a any PAL or NTSC video playback receiver / TV. Doesn't matter whether it's LCD like this or whether it's good old CRT. Still need that analog delay line. And I am going to have to actually power this thing up. I got it at 6 volts here because to do that, it's electronic eject on the thing. So there you go. I thought it might help to take, there we go, genuine Sony Video 8 thing. And click here if you haven't seen what's on this tape. It's interesting. And it didn't have the arrows on there, but it's pretty obvious that this top cover had to come off with 2 screws here before the tape mechanism will lift out. So here we go. We've got the Sony marked screws off, and it's not quite going to come out. There we go. It's going to swing out. Look at that. We're in like Flynn. Wow, what a Bobby Dazzler. Look at our tape mechanism. Look at our drum. Beautiful. Oh, classic 1980s. Hang on. Yep, smells like late 80s too. And these things were a marvel of engineering at the time because, well, they still are. I mean, just the amount of fit-to-envelope design that they got to do for this thing, all of the intricate detail of the buttons and everything, the mold in the case. There's very little wasted space in here in terms of the boards are packed. They're using flat flex, of course, to connect things through, but there's very little volume wasted in this puppy at all. Of course, mixed through hole and surface mount double-sided load technology. This button board on the top and the whole tape transport mechanism. They've got one, looks like one main board down the bottom here, but yeah, there's very little wasted space in all that, let me tell you. So absolutely amazing technology. You've got to remember, they designed this in, you know, the mid-80s. They would have been working on this for a couple of years before they finally got it to production in 1988, 1989 for this particular model. And it's just absolute, and the tools they had at the time to actually do this sort of, to design this sort of stuff, it's just phenomenal. Sony were absolutely brilliant at making stuff back then. Don't know what size team would have worked on this, but geez, it would have been a lot, let me tell you. There's just a stunning amount of tiny little things you could go through. I could spend hours and hours going through all the, you know, the fine details of all the mechanics of it and everything else, let alone the electronics side of the thing. Phenomenal. And check out the old school LEDs in here. None of this surface mount rubbish. This was surface mount back in the day, through hole. They didn't bend the legs underneath. You could actually buy them like this, and then you could either actually kind of like surface mount them in the board. You could have a little cutout in the board and actually push it down and then have the legs soldered to surface mount pads either side, or you can do what they've done here. They probably got them maybe formed at that particular length from the factory, like that, and they've got another one for the green LED here. But yeah, that's how you did surface mount LEDs back in the day. Of course, all the that's the eject button there, which has to mate up with the eject stuff on the side of the case here. So that's, you know, so the spring loading was actually inside the switch on that thing. And there's the power button, of course. It's a spring-loaded puppy as well. And of course, Sony made absolutely everything themselves back in the day, including all their own chips and their own speakers. It's upside down. And obviously what we've got under the cans here, here's our telescopic rod antenna, and that's going, so this is going to be our RF front end tuner, everything else under these cans. And this is all your video processing board, which makes sense that it then couples into the tape, because hey, it's analog coming off the tape, none of this digital rubbish. So whether or not you were sourcing the video from your TV signal or from your tape, hey, the rest of it didn't care. That's why this would process the video, put it into the PAL format, and then it'd go over the ribbon cable, and then the ribbon cable is what goes over to the main LCD, and that's where all, well, yes, I did take it apart. I put it screwed it back to keep it back in, but that is where all the analog to digital processing takes place to display on the LCD. And of course, it wouldn't be complete without a genuine bodge. Look at that little through-hole cap. Just add a couple of puff there, no worries. Fix whatever issue they had at the time. And of course, because this was all wave soldered, none of this reflow rubbish with solder paste, all this surface mount, it was, all these components were stuck down. You can see the little red things under the components there. That's actually the glue holding down the individual parts. They stick them down there, hold them onto the board, and then this board passes through the bubble bath, the wave soldering process. There we go. And even the IC stuck down there. And we've got some solder feed-in pad there, which wicks away some of the solder to stop shorts as the molten wave passes over this board. So there you go. Classic stuff. Still done these days, but yeah, not nearly as much. Only in really low-priced, high-volume consumer gear. Still done in some TV sets and power supplies and things like that. You'll still commonly see this sort of done, but not for, you know, main logic boards and things like that these days. And there's our video head down in there. That looks pretty clean. No worries. There's another one. And another one. And another one. Woohoo! See, that looks as clean as a whistle, doesn't it? Beautiful. Look at this. We got ourselves our... Whoop. Oh, that's a bit... How you doing? It's got our little cleaner on there. So we can get clean our little video heads right in there as they spin. Look at that. Of course, they spin at an axis across the tape. That's how these... if you're wondering why the head is on an angle like that, that's how they scanned the actual tape directly across in sort of angled lines like that. And you can see the guide paths in here for the various rollers, like the tape guides that would actually wrap the tape. They'd pull the tape out like this and then wrap it around the drum head like that. So that's why we've got two slots down there. And in case you're wondering, yes, it is only the top half of the drum that the actual heads that actually spin there. The bottom part doesn't. And you'll notice that we've got angled tape guides as well in there. One angled that way for the head and the other one obviously angled down that way to wrap the tape around at the head at a particular angle. All right, I'm going to be a real cheeky bugger here and see if I can actually put a tape in this thing with it in this position. So hopefully it should still work. They would have designed it like this, I believe, so that, you know, you could swing out this control board on the front and still power the thing up and actually access the tape and do stuff. I'm sure they would have designed it like this. So let's see if we can still eject. Ta-da! We can eject that. No worries. Let's put our tape in. And there we go. Alright, so let's power this thing up. Woohoo! There we go! We wrapped our tape around! Look at that! Beautiful! Bobby Dazzler, let's press our play button so you can now see the tape. Sorry, it's quite hard to move this. You can now see our tape wrapped around the head there. There we go. At the angle, of course, hence those angled rollers. And let's see if we can hit the play button here. And whoop, there we go. And took up a bit of slack on that, but there we go. It's playing. Absolutely brilliant. Let's stop. Whoop, and let's eject that puppy back out, shall we? Ta-da! Beautiful. Can't get enough of that. Let's put that back in. Fantastic. And for those who enjoy tape transport mechanisms, there's the rest of it all down in there. Complex beast. You can actually see the micro switch. Whoop. Yep. Down in there, that little plunger hooked onto that flat flex there, and that, of course, is for the write protect on the tape. So it goes through those holes there and determines whether or not you are going to be able to write to that tape or not. And if we pop the tuner and video processing board, so to speak, up here, then you can see more of the 3D envelope design. You can see the tuner here, how that fits into this space down in here. They've even got the plastic sheeting down on there for the insulation on that main board down the bottom there. and it's brilliant. Look at it. It all just fits in there. This just fits around this pillar post here. For example, this front end RF block just fits in there nicely, and they've cut out this black plastic insulating sheet as well. Why they needed that insulating sheet, I'm not entirely sure. But anyway, they've just jammed it all in there like that. And they've even jammed another can down in here. I'm not sure. Oh, is that tied? Is that... That might be actually tight. That might be on either side of this main board down the bottom here. We won't know unless we get that bottom board out. Maybe that's, I don't know. Is that like a little switch-in power supply, perhaps, for powering the analog board? Not sure. And there you go. That's for all you tuner aficionados. I know you're out there. Oh, look at all the subsections. Lovely. Just hand-tweaked with the tongue at the right angle. Beautiful. And you've got to have the obligatory wax gunk in there, of course. And by the way, if you don't know why they add the wax gunk down in there, that's to, once they've tuned these coils, they've got the spacing just right. They'll whack the wax in there so that the coils can't move with, you know, vibration, stress, or anything else. So it just keeps them in place. And wax was, or waxy type stuff, not sure of the, like, you know, beeswax or whatever it was just, you know, the stuff of choice back then. And that's under the can for the backside of our RF front end, because here's the antenna connection here, basically, and that's going to bugger off into here. And what's that thing? I don't know. If anyone's got any specs for that unusual looking metal can there, what is it, some sort of RF preamp or something like that? I don't know. Weird. And if we flip the whole mechanism out, and yes, it is still all attached to the mechanism like this. It's all on one big board. Isn't that beautifully modular like that? We can see down in the bottom of the case, this is an insulating plastic sheet here, and that goes down to the, well, that's still plastic back sheet with the vent holes on the thing. And look, we've got a fair bit of business happening on the back of this baby. Wow, look at that. We've got ourselves a, look at this, a chip on board hybrid module here. That's because a lot of this will be doing like the on-screen, I believe it had on-screen display, if memory serves me correctly, when we did that. So a lot of that will be happening in there. Once again, I do think that's probably the DC to DC power brick that we saw before that I mentioned. Not sure what's happening under these cans, but once again, all custom Sony parts. Everything's custom Sony. You might be able to look up, maybe if you're lucky, get some data on that. But geez, yeah, it's just Sony. They did everything. And this copper strap here seems to be a bit of an afterthought. Look at that. And there's maybe a reason why it's that thick. It's connecting the shield of these cans, but is it fixing a goof, like making a lower impedance on the PCB, for example? Because this is only a double-sided board. So, you know, look at all these traces coming out of here, like dozens of them. And yeah, maybe they had to get across, or are they trying to shield something, get a lower inductance path between these two shielded cans? Is it like a RFI fix? Is it a ground fix? What is it? But yeah, it seems a bit of an afterthought. Now this big shielded can here, which does actually connect down onto the main baseboard down here, that's actually the camera interface, because these cables that come out here from it, they go over to the little board on the side, little multi-way connector board on the side that connects through to the custom Sony camera interface. Once again, they got a big copper strap over there, and it goes all the way over. So what are they? They're, you know, you've already got your shielded can there, so obviously they're trying to get ground around the place, and maybe that's the way that they got a low impedance path across. But yeah, it's quite unusual. You can see that actually connect into the main board there, and it's all, wow, it's all getting a bit ugly now. And if we go start taking off the tape mechanism, which is in this thing, wow, it's that is a lot of engineering that goes into getting this thing together. Wow, it's incredible. Oh, careful, don't touch the head there. But it looks like a mess, doesn't it? But this is typical of Sony gear. I might have to link in my like old Sony Handycam teardown from the early 80s, I think it was. Was it the world's first camcorder or something? But yeah, it was like very densely packed, kind of like this thing. But this is what you had to do to get a portable video device back in the late 1980s. I mean, you know, smartphone in your pocket, you take it for granted now, but gee, you know, like no solid state storage back then. It was all still analog, 8mm tape in there. And all analog, none of this digital rubbish. And yeah, sure, we had to have some digital processing to get like the menus up on the video overlay. But that was like PAL video going off to the screen here on this thing. I mean, just wow. It's just easy to forget how far we've come from, you know, these pure analog or, you know, quasi analog digital sister hybrid systems, because, you know, once you've got to have digital, have the text overlay on there, but it's all analog signal go into this thing. It's like, it's incredible. Wow. March of technology. It's amazing. So let's just go in and take a quick squiz at our LCD display here, because I think we might see something rather interesting under here. Look at these big ass terminals here. Okay, hold on to your hat. Let's lift it up. Ta-da! Cold cathode tubes. Look at that for our backlight with the reflector. And that's how they got the even backlight on the LCD display. Unbelievable. Look at that. And obviously the brick here, this shielded can is our high voltage driver there, and you can actually see the output of that. There you go. See the output of there driving our CCFL backlight. Old school. So as you can see, this really doesn't have any display processing at all, really. We've got just the flat flex going down to the LCD, which would be under here. We'll try and take a look at that. But yeah, all of the on-screen display processing would have been done on the other main board, which were the SAW down in there. So all this is likely doing is taking the PAL video signal and just actually displaying it. And this Mitsubishi M51403FP, this is, you guessed it, a PAL video chroma processor. And here's a look inside this thing, designed specifically for LCD, you know, converting PAL signals and for LCD TVs. That's its job, and that's why inside this puppy, you don't see much else. Well, Sony made everything except the LCD. That's a sharp jobby. Still made in Japan. All the best stuff's made in Japan. So that's a real interesting module they've got there. Look, we've just got single ribbon cable going into that. That's it. And look, that's the LCD. And it's all shielded. Beautiful. And of course the backlight, as we saw, shines through the back here, because LCDs, unless they're, in this case, it's going to be a trans-reflective display, which means that it does reflect some stuff, but also allows light, i.e. backlight, to transfer through. If it was just a reflective display, then you wouldn't be able to backlight the thing, because you wouldn't be able to see through it. And no surprises for finding a Sharp chipset in here, because, well, Sharp were the LCD kings back in the day. No surprise whatsoever that Sony went to them and say, hey, we need this module, these specs or whatever. I can't remember the resolution. I don't even know if this was full like PAL or NTSC resolution. You know, 576 lines or whatever it was. I'm not entirely sure of the specs. I'll have to check that. But yeah, anyway, here we have our flat flexes going over. It's mounted in its own custom frame. I might have to take this out and have a look. But these are our column drivers and our row driver flat flex interface, that's all gunked down. Of course, that'd all be hotbar attachment across here. It's not particularly high pitched, so reliability probably wasn't an issue. Unlike some certain fluke graphical multimeters we won't mention, and graphical oscilloscopes. And I almost forgot, we finally have ourselves a date code, 1989, 31st week. And there's the backside of it, and obviously we're going to have chip on flex because there's just not enough connections going over here. So the actual row and column drivers would be on the flex tucked in under there, and you can see just these small number of connections going over, and then much larger connections. If you want to get in there and view this in HD, and this display is actually a really nice design. Look how it sort of folds back, and the chips on the flex on there, the drivers, are tucked back under like that. I mean, that is just brilliant, brilliant design to try and get the form factor as small as possible. Not only width and, your horizontal and vertical dimensions like that, but also your height and everything else, your thickness. Like, it's absolutely incredible. So there we go. We can start seeing our chip on flex down in there. There we go. They're all blobbed, but it's sort of like sandwiches in like that. It's that is great. So hats off to Sharp for that. That's beautiful. Like manufacturing that, I don't know. I'd probably be okay. You get a jig to bend the cables and everything, and then hotbar them down, and yeah. There you go, for you HD aficionados. Count the number of columns there. There you go. Go on. And the number of rows while you're at it. And what I thought might have been a DC to DC converter block wasn't. That is our, of course, head amplifier coming from the video head, because if I followed I couldn't see it before, but because it was covered like that, I should have followed the cable. So they're our shielded coaxes coming from or shielded pairs coming from our video head, and that's our video head amplifier. We've got ourselves quite a few trimmers in there. I count 5 of those puppies, another one under there. And interesting to note that they've got a populated header connector inside here. So this obviously it's not going anywhere apart from the production test stage. That's what it must be. Production test head alignment perhaps, or some other setup for trimming the pots, because the pots are there for some reason. Somebody trimmed all the pots on this baby. I know all you tape transport aficionados want to see the bottom side of the video tape transport. There it is. Oh, beautiful. I won't even try and go into detail of how that baby works, but oh, look. A little drive there, and that drives that cog, and that drives that cog, and oh my goodness, imagine the team just working on the tape transport mechanism alone, let alone the RF electronics, let alone the display technology, let alone the the mechanical design and everything else. How many teams worked on this thing? And if we have a look at the board on the bottom here, ta-da, I've already popped off the hood on one of the cans there, and you might notice that looks like a tuna can, so you know it's doing analog goodness. And if you have a look at that part number, the Sony CXL1502M, that is the CCD video processor. So once again, how many people worked on just that video processor chip? But they would have used it in tons of products back in the day. But yeah, we've got some trim pots on the outside of that puppy. In fact, lots. Count them. 2, 4, 6, 8, 10 at least. Wow. And there's our power supply. I was kind of right. Look, they've added, like I thought it might be inside a shielded can. They've actually added, they've added a little shielding tape. They haven't bothered to ground that unless it was connecting, making contact to something else. But they're just putting that over some of the caps and the inductor there by the looks of it. But yeah, they've made a little attempt to do that. Or is that, yeah, no, it's shielding. They've metallized that. They haven't just put in like a piece of mylar or something like that. There's a little DC to DC converter can. There you go, Bobby Dazzler. And under that can there, we've got ourselves a Looks like an oscillator. Discrete transistor oscillator by the looks of it. Interesting. And if you remember back, these are the two cans that were strapped together with that big copper strap there. Look at that. So there's obviously, there might be something on the bottom side of that, but this one's a DC to DC converter block and an oscillator block basically. So there you go. I hope you enjoyed that. Look inside this classic Sony late 80s vintage video Walkman. It doesn't get much state-of-the-art than this in the late 80s. Unbelievable amount of engineering went into this. If you had one of these things, let us know what it was like back in the day. Was it as groundbreaking as, well, it appeared? But hey, it just... the lifespan of this thing just would not have been that great. It would have been dominated. I don't know. What was the next thing out? If anyone knows what was the next item out there that sort of, you know, surpassed this in terms of, you know, in terms of portable video devices, or just did nobody care about portable video devices? They didn't want one. They were too big, too heavy. They just didn't really have the need for them because, well, you know, you watched portable TVs were around at the time, and yeah, this was a portable TV, but it tried to combine the 8mm tape recording as well, and yeah, probably a few professionals used them for on-site recording from cameras and stuff like that. Maybe, I don't know. Hence the camera interface. Let us know. It's always fascinating taking a look at these vintage devices just for that. I just love the amount of engineering that goes into these things. I've said it time and time again. Absolutely brilliant. Anyway, I hope you enjoyed it as much as I did. And as always, there will be high-res teardown photos on EEVblog.com. So that's linked in down below. And if you liked it, give it a big thumbs up. Catch you next time. As we said before, if you haven't seen the previous video, there's two acoustic transducers up the top. Let's draw a little graph here of a typical response characteristic of these things, and they are tuned to the character frequency. We can see our delay here, the yellow waveforms, our input. Of course, that's our burst of 4.4 megahertz sine waves there, and we've got, if you actually count them, you'll get 108 or whatever it is.